Hello friends and welcome to another tutorial on Geeks for Geeks. In this video, we are going to understand the tree isomorphism problem. First, let us understand what exactly is tree isomorphism. Two trees are called isomorphic if one of them can be obtained from other by a series of flips, that is, by swapping left and right children of a number of nodes. Now, let us see the algorithm which will assist us in checking if two trees are isomorphic. Let us also have sample trees to test our algorithm. We pass the root nodes of both trees to function is isomorphic. So, n1 and n2 will point to 1, which is the root node in both the trees. Now, we check if n1 and n2 is null. As it is not, we check if either of them is null. As this is false as well, we compare the data of n1 and n2. As it is equal, we call the isomorphic function with n1's left and n2's left. So n1 will point to 2 and n2 will point to 3. Now, as n1 and n2 are not equal, we return false. As the first part is false and we have an AND operator, so the complete expression will be false. Now we pass the left child of 1, which is 2, and the right child of n2, which is also 2. So n1 and n2 will point to 2. Since n1's data is equal to n2's data, we call the isomorphic function with n1's left and n2's right. As both of them are equal, we check for n1's right and n2's right. As the right child of 4 is null in both the trees, so we return true. Now we check for n1's right and n2's right. So n1 and n2 will both be equal to 5. As both are equal, we call for the left child of n1 and n2. Since node 5 does not have left child, it is null and we return true. Also, n1's left and n2's right is also null, so we return true. As both are equal, we call for the left child of n1 and n2. True ANDed with true will be true, and it doesn't matter if is isomorphic 4 5 and is isomorphic 5 4 will be true or false, as there is an OR operator. So we return true. Now we pass n1's right and n2's left. Since both are equal, we call n1's left and n2's left. As you can see, n1 is 6 but n2 is null, so we return false. As one of the result is false, the whole result will be false. Now we go to the OR part and pass n1's left and n2's right. So n1 and n2 will now point to 6. Since n1 and n2 are equal, we call for the left child of n1 and left child of n2. As both are null, we return true. Now we pass null to both n1 and n2. Since both n1 and n2 are null, we return true. As false ORed with true is true, we return true. As true and true is true, we now have false or true. Since false or true is true, we return true, and hence these trees are isomorphic. With this, we finish execution of this program. Now let us have a look at the time complexity of the program. This code will run in big O of m plus n complexity. Here, m and n are the number of nodes in the two binary trees. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.